Alright, so this is from Year 2 Further Maths, exercise 2.2, and it's question 5. So in case you haven't had a chance to see the question yet, take a look at this. You can pause the video and go ahead and have a go before watching the solution. Okay, so hopefully you've paused the video and had a go. So let's take a look at this then. So we've got a matrix equation. We've got two things here which we don't know straight away in our matrices. Obviously we're trying to solve for x, y and z here. And this matrix equation also can represent the intersection of three planes, or the arrangement of three planes, and it says we want to interpret the solutions with reference to three planes here. So if the three planes here would have the Cartesian equations x plus 3y minus 2z equals minus 2, minus 3x plus y plus mz equals 6, and minus 3x plus 11y minus 4z equals k. Okay, so that's just taking, remember those are just the coefficients, each row of the matrix there is the coefficients, and that's going to be what it equals on the other side. So we want to interpret in terms of those three planes. So what we can do first here is you could do these one by one, plugging in the values and trying to work them out. But it's actually might save a bit of time to work out the determinant of this matrix algebraically first, so that you can see what patterns there are. So if we say that that's M, capital M it would be, then the determinant of that large matrix is, so we're going to take, I'm going to do it by the first column because it doesn't look like any of them are going to be especially easy. So remember, we take the first number, so 1, and times it by the determinant of the minus. That would be, we cross out this and we cross out this. So that's going to be minus 4 minus 11m. Okay, then our next one, we are going to use this minus 3, but then of course remember the middle is going to have another minus, so that's going to end up being plus 3, and then the minor of that, crossing out that and that, we end up with minus 12 minus 22, so plus 22. And then the last one, we've got minus 3, this one, sign stays the same. Crossing out that line and that line, we've got 3m minus 2, which is plus 2. Now simplifying that down, we end up with minus 4 minus 11m minus 36 plus 66 minus 9m minus 6, and simplifying that even more, we end up with 20. So minus 4 minus 36 plus 66 minus 6 is 20, and then minus 11m minus 9m is minus 20m. So that means that this would equal 0 if m equaled 1. Obviously we want to think about the important time when the determinant is 0, because that means the matrix is singular, so it doesn't have an inverse. So this tells us m is singular when small m equals 1. Okay, because that would make the determinant 0. So any other time when it doesn't equal 1, it's non-singular, which means that this equation at the top will have a unique solution. So looking at our different cases here, we can see that, look, here we've got m equals 2, it's going to be non-singular, so that one will have a unique solution, but these two, m is 1, m will be singular. Okay, so this matrix will be singular. So let's first do number 1, because that's going to be a bit easier because it's non-singular. So for number 1, m equals 2, k equals 3. That means we've got the equation, 1, 3, minus 2. Okay, so I've just rewritten that, but I've substituted 2 for m there and then k for 3 there. And now we can solve this equation by actually just multiplying both sides by the inverse of this. So that is going to leave us with x, y, z equals inverse of that times by that, and that will give us the answer. Now you could find out this inverse by hand using the determinant that we just worked out and the method that you hopefully will have seen in previous videos, but in fact we don't really need to, and it would probably save time to just use a calculator to do this. So hopefully you're going to be able to see what I'm doing on the calculator screen. This is just your normal ClassWiz calculator. So we need to go to menu and matrix there, which is number 4. Then we're going to define 2 matrices. So let's call this one matrix A, well actually this one. And we're just going to do 3 by 3, and we're going to type in the numbers 1, 3, okay, then we've done that one, clear, then we do option, we need to define another matrix, which is going to be this one, so let's call that matrix B, 3 rows, 1 column, minus 2, 6, 3. Okay, so now we've got our 2 matrices, and what we want to do is type this in, so that's matrix A, then we press that button to give us the inverse, then we want to multiply that by matrix B, and that will give us our x, y, z. So that tells us x, y, z equals minus 0.8, 0.6, 1.5. Okay, so that tells us that in this case pi 1, pi 2 and pi 3 intersect at a single point, so we can say at the unique point minus 0.8, 0.6, 1.5. Those are the coordinates of that unique point of intersection. Okay, so that's number 1 done. And now let's have a look at number 2 and number 3. So I think it will probably be easier to actually do these together. So because they both have the same value of m, we know that they're both going to have a determinant of 0. So we know that what we need to do is investigate these equations and see if we end up with something consistent or inconsistent to decide what the arrangement is. There's definitely not one unique intersection. We can look carefully at these and we can see none of them are parallel because these coefficients are not multiples of each other. So it's going to be either sheaf or triangular prism. So we need to work out which one these two are. So let's rewrite these equations then using our m equals 1. But like I say, I want to do them together, so I'm going to actually leave that one as k just to begin with. And then hopefully you'll see why. So we've got x plus 3y minus 2z equals minus 2. We've got minus 3x plus y, and we're going to have m as 1 plus z equals 6. Then we're going to have minus 3x plus 11y minus 4z equals k. So I've got my 1, 2 and 3, and what I want to do is eliminate one of the variables. So I want to end up with 2 equations in 2 variables instead of 3 equations in 3 variables. So I think because we've got both 3x here, it might be easy to eliminate x. So let's do that. So we can add, take away 2 minus 3. And that's going to leave us with, so minus 3x minus 3x, 0, which is what we wanted. Then we've got y minus 11y is going to give us minus 10y. Then we've got z minus 4z is going to give us 5z. And then over here we've got 6 minus k. All right, and then I want to choose a different pair to eliminate x as well. So let's use 1 and 2. So let's multiply 1 by 3 and then add that to 2, because then we'll have opposite signs. So that's 3x plus minus 3x, 0. 9y plus y is 10y. Minus 6z plus z is minus 5z. And we have minus 6 plus 6 is 0. Okay, and hopefully we can see these are very, very similar. If I just multiply everything in this by -1, that will keep it this equivalent. So I have minus 10y plus 5z still equals 0. So I don't actually need to worry about that one. We can see that these two are the same on the left-hand side. So to be consistent, they would need to also be the same on the right-hand side. So consistent if k equals 6, because then 6 minus 6 would be 0. Which, look, that's number 3. And obviously k equals 3 would be inconsistent, because then that would be equals 3 and that would be equals 0. Inconsistent if k equals 3. So if they're consistent, that means they are arranged as a sheaf. They intersect along one straight line. If they're inconsistent, that means they are a prism, a triangular prism. Okay, and that's all your answers. So that's the answers to part 2. Inconsistent if k equals 3, they form a triangular prism. So there are no points of intersection between all 3 curves. And that's your answer to part 3. They are consistent if k equals 6. They form a sheaf and intersect along one straight line. Infinite points of intersection.